Aloha guys, this is Dr. Tom coming at you once again. Today we're going to study one of my favorite systems, or start on it, the endocrine system. I'm not sure why it's one of my favorite. I think it's just the incredible power that a few molecules, these hormones, have. Okay, I want to take a moment to talk about something. A couple of months ago I started this YouTube channel to promote a book that I wrote years ago. It's still available, called The Force is With Us. Why? Because it gets great reviews, but it doesn't sell, and I'm tired of it. I'm going to give it one more push. So it's a groundbreaking book, but so what? There's lots of other ones out there. Now, after I did that, I already had the channel up. I thought, online, maybe I could record these PowerPoints and it would help the students some. And the feedback I've gotten has been really good. However, I've noticed something. The viewership is falling off. I can go on YouTube and see how many times it's been viewed. It doesn't tell who viewed it, but it darn sure tells how many has viewed it. The last two I did was on this was the previous to this one on the sensory system, and out of my nearly 40 students, it's had 5 views, and we got one more week until the module ends. Now, guys, I know things start getting busy, but I resent that. And so, if you don't watch them, I ain't gonna make them no more. So think about that. All right, the endocrine glands. Endocrine glands are ductless glands. They're released into the bloodstream. They secrete hormones widely distributed throughout the body. Here they are. The hypothalamus is part of the brain, as you might recall, but it's also closely associated with the endocrine system. Pineal gland, pituitary is the master gland, the thyroid, parathyroids, thymus gland, adrenal glands on top of the kidneys, add renal on top of. See, sometimes it makes sense. Pancreas is both an endocrine and an exocrine gland, and testes in the male, ovaries in the female. Those are the endocrine glands. Hormones, chemical messengers that influence and control activities of other tissues and organs. They're either protein or protein related or steroid. Steroid hormones have cholesterol. It's another of the important jobs of cholesterol. It's not the evil villain that it's always made out to be. Hormone targets. Now, by definition, endocrine glands secrete into the bloodstream. The hormones circulate till they get to the proper target, and then they stimulate it. Many target tissues result in more widespread effects. With fewer target tissues come fewer effects. Okay. So there are target tissues for these specific hormones. Hormone receptors. Gland aims hormone at target organs. Hormone activates receptors on cell membrane or within the cell nucleus. Some of them go into the nucleus. Some of them do it on, a great number of them guys do it on, there's a lot of activity takes place on the outside of the cell. It's extraordinarily complex. Control. We have a negative and a positive feedback system on different ones. Biorhythms, circadian and monthly, central nervous system, psychoneuroendocrinology. What we think about things, guys, affects our hormones too, but that can be said of the whole body. Now, for the endocrine system, most of the feedback is a negative feedback, and we'll go over that. It's simple to understand. I'm going to give you an easier example. Think of your home thermostat. You set the AC on 70, and when the temperature rises above 70, it kicks on. If you have AC, I don't, but we're in Hawaii, man, bro. Am I doing that right? And then it'll cool until it drops down to 70, and then it'll kick off. That, friends, is a perfect example of negative feedback. Most of the control is by negative feedback. If you want to read about this one, you can. Positive feedback is less common, and it's a little harder to understand. A bodily change stimulates further change in the same direction. The following are some examples. During labor, pressure on a baby's head on the cervix stimulates the release of oxytocin, one of the pituitary hormones. Oxytocin stimulates uterine contraction, further increasing pressure in the cervix, and so on until the cycle ends when delivery is accomplished. There are more negative feedback than positive feedback in the body. Okay, now, the master gland is the pituitary gland. This is really important. If you don't get anything else, you need to get this. The master gland is the pituitary gland. It is closely associated with the hypothalamus, part of the diencephalon. Remember the thalamus and the hypothalamus? The hypothalamus controls the pituitary. The pituitary controls everything else. So these are big time super important. There's an anterior pituitary and a posterior pituitary gland. The hypothalamus is connected to the anterior pituitary through blood capillaries, little tiny blood vessels, and to the posterior pituitary through tissue extension. In other words, the posterior pituitary gland joins right into the hypothalamus. Big time important. Big time. Okay. Just to make things more complicated, the anterior pituitary is also known as the adenohypophysis. Adeno means gland, controlled by releasing hormones of the hypothalamus. The posterior pituitary is known as the neurohypophysis. Why? Because it's nerve tissue that connects directly to the hypothalamus. It's actually an extension of the hypothalamus. So this is super important, guys. Anterior pituitary adenohypophysis, posterior is the neurohypophysis. The pituitary controls the entire endocrine system, but it in turn is controlled by the hypothalamus. Okay, now this looks kind of complex, but it's only because it is. Now, here's the anterior pituitary and here's the posterior. Posterior only has two hormones, but we're going to talk about the anterior pituitary. It has thyroid. TSH is thyroid stimulating hormone, works on the thyroid gland. ACTH works on the adrenal glands. Growth hormone works on the whole body. Gonadotropins, FSH and LH, on the testes and the male ovaries and the breast tissue in the female, because it has to do with breastfeeding also. Prolactin works on the breast, FSH and LH on the gonads. Okay, that's the anterior pituitary hormones. We're going to talk about them all separately here in a moment. The posterior pituitary are two. ADH, which is antidiuretic hormone, and oxytocin, which has to do with uterine contractions during birthing and milk letdown reflex during nursing. Here it shows the blood vessel, the capillary beds, and the anterior pituitary, and here are the nerves of the posterior pituitary, an extension of the hypothalamus. So what ultimately controls everything, guys? I'm listening. Nobody's answering. Oh, I forgot. It's because I'm here by myself. What was the question now? The hypothalamus controls everything, ultimately. Extraordinarily complex, like everything else in the body. Okay, growth hormone, called somatotropin, or just human growth hormone. Affects bone, cartilage, skeletal muscle, causes amino acids to build into proteins, fats to be used for energy, converts proteins to glucose, exerts a profound effect on growth. If you have an excess of growth hormone before your epiphyseal plates fuse on the long bones, you can grow into be a giant. If you have a deficiency of it, you can be a dwarf. And dwarf is an acceptable term, and for some reason, a midget is not. But they're not the same. They're both little, but. Anterior pituitary prolactin, also called lactogen. Now, lact, of course, means milk. Stimulates the growth of mammary glands, hopefully just in the female. So prolactin has to do with milk, with breast development in the female. Tropic hormones. Okay. Now the anterior or the pituitary gland, the master gland, controls everything else. The way it controls the thyroid gland, which is in here, is through thyroid stimulating hormone, or TSH. Now, it's perfectly acceptable to call it TSH. Everybody does. Adrenal corticotropin hormone, or ACTH, naturally they call it that because that's a big word, affects the adrenal cortex. The adrenal glands have a medullary portion and a cortex. We'll go over it in a minute. Gonadotropin hormones has to do with the gonadotropic, has to do with the gonads. Now, what this is these are all tropic hormones that I wish they wouldn't do that. I'd rather they introduce the individual ones first. Okay, well, they've already talked about it. Okay, posterior or neurohypophysis has two hormones. The antidiuretic hormone, or ADH, and oxytocin. Here they are. ADH helps prevents the kidney from releasing too much water. If you have a deficiency of ADH, you'll develop a disease called diabetes insipidus. Now, it has nothing to do with diabetes mellitus, the blood sugar disorder. This is one where you're peeing like crazy. So you need ADH to stop that. Oxytocin, the famous milk letdown reflex that releases milk to a nursing female. Okay, ADH or antidiuretic hormone released to conserve water, primary targets the kidney. Absence of ADH results in, here it is, diabetes insipidus. Causes blood vessels to constrict, which elevate blood pressure. You will pee like crazy if you have diabetes insipidus. I would imagine you could give supplements of it, and I'm not sure how it's treated, and it would hopefully correct it. Okay, the other posterior pituitary hormone is oxytocin. Target organs are the female uterus and the mammary glands. Nervous system sends signals via the neuroendocrine reflex. When baby breastfeeds, oxytocin is released and stimulates contraction of smooth muscle around the mammary ducts to release milk. That's the milk letdown reflex. Okay, thyroid gland. The thyroid gland produces a couple of very important hormones that deal with metabolism. It sets our metabolic rate, and they are T3 and T4. T3 is triiodothyronine. I forget the T4 is a more difficult word. I forget it. FSH releases T3 and T4 into the blood. Also, too, guys, the thyroid gland and the 4 little tiny parathyroid glands regulate the levels of blood calcium, serum calcium in the bloodstream. It's real important. The thyroid gland also produces a chemical called calcitonin, which moves calcium out of the blood and into the bone. Okay, so there's three things, T3, T4, and calcitonin, that the thyroid gland produces and releases. Here it is. T3 and T4 regulate metabolism, the rate with which we build and burn energy and all. Permit proper function of all other hormones, promote normal maturation of the nervous system, promote normal growth and development. Calcitonin helps regulate, as in calcium, regulates calcium levels in the blood. Excuse me, I was too lazy to raise my arm up. Abnormal thyroid secretion. Hypothyroidism, deficiency of T3 and 4 can result in a disease called myxedema. They're heavy and depressed, and then the exact opposite of that is Graves' disease, hyperthyroidism, accelerated metabolic rate. They're skinny and their eyes bug out and they're all nervous and dry skin, no wet skin, I forget. How is the T3 and T4 controlled? Well, it's quite simple. It's controlled by TRH, thyroid releasing hormone. No, I'm sorry. As you were, TRH comes from the hypothalamus. TSH comes from the anterior pituitary gland. And like most, it's controlled by a negative feedback. So hypothalamus secretes this, causes the anterior pituitary to secrete this, which causes the thyroid gland to secrete these. Both of these are controlled by a negative feedback loop. How do I know? Because I know, but also it's got that little minus sign there. Okay. The element iodine is essential for health, and it's an important constituent of T3 and T4. And if there's a shortage of it, you can develop what's called a goiter. Now, you don't see goiters much anymore, but you used to when I was a kid. What they started doing, guys, was they started adding iodine into table salt. And that little bit of additional salt, iodine, when we salted our food, was enough to prevent this. So a tiny little bit of iodine is absolutely essential. Why? Because it's an ingredient of these triiodothyronine and tetraiodol. There's the iodine part of it. Thyrine. Calcitonin, released by the thyroid gland, regulates blood, stimulates osteoblasts, increases excretion of calcium phosphate in the urine. So if the blood levels of calcium get too high, they have to be kept within 9 to 11 milligrams %. So you didn't think I'd remember that? The thyroid gland will secrete calcitonin and bring it back down. Okay, we're about to run out of time. We will finish up in the next video. Watch these videos. I know when you're watching. I'm like Santa Claus. Dr. Tom signing off. See you next time.